Lesson 76, multiplying radical expressions. So if you remember, we talked about this, I think, before, where if we had the square root of two numbers that are multiplied, it's equal to the square root of one of them times the square root of the other. So you can take the square root of each factor to take the square root of the product. So here's an example. If we had the square root of 2 times the square root of 50, we could just square root of 100, because 2 times 50 is 100, and we know that to be 10. Here's another example. 3 square roots of 2 times 5 square root of 7. Now when we're multiplying, you can only multiply the ones that are outside together, and then you have to put your square root and multiply the ones that are inside together. 2 and 7 are not perfect squares. There's no factors that we can get a perfect square out of this. So we just do 3 times 5, 15, and then you have the square root of 14. Now if we had, how about this one? 4 square roots of 6 quantity squared. So this means we're going to do 4 squared, and we're going to do the square root of 6 squared. A square root of a number squared is just that, radicand. So this is going to be 16 times 6, which is then 96. And here's another example. Right here I'm just going to write examples. There we go. So what if we had 3 square roots of 6x times square root of 2x? So this is just a 3 on the outside, that stays there. Underneath the square root, instead of writing 6, I'm going to write 3 times 2 times x, and then we have times the 2x. So we are looking for doubles, because the square root of 2 times 2 is the same thing as the square root of 4, which is just 2. And then the square root of x squared is x, and we're left with a 3 that didn't have a partner there. So we have 3 times 2. 3 times 2 is 6x square roots of 3, and that's simplified. Sometimes we have to use a distributive property. So we have, how about this one? Square root of 3 times 8 plus the square root of 6. So when we use a distributive property, we're going to do 8 times the square root of 3. So we have 8 square roots of 3 plus, then we're going to square root 3 times 6. So this is 8 root 3 plus, let's write 6 as 3 times 2, which the square root of 9 is just 3. And we have 8 square root of 3 plus 3 square roots of 2. Let's see. Here's an example with binomials. So you can still use FOIL or whatever you like to use. So here's a binomial, 3 plus square root of 2 in parentheses times 6 minus root 5 in parentheses. So we do the outside, first. So 6 times 3 is 18. Then we multiply the last, negative 3 times the square root of 5. Then we do the insides, which is a plus 6 square roots of 2. Then we do the last. So we have a negative square root of 5 times square root of 2. So minus square root of 5 times 2, which is just a 10 there. So we have 18 minus 3 root 5 plus 6 root 2 minus square root of 10. Since all of these radicands are different, we cannot add those or subtract them together. That's the end of the lesson.